flavor is vanilla and chocolate. So ladies and gentlemen, please give Alkin a warm welcome. And it's your day now.
Thank you for the introduction. Okay, this is a nice introduction on the ice cream. Chocolate and vanilla is nice. So unified observability is our subject today. Thank you for coming, and thank you for the organizers inviting us over here all the way from. I'm from Istanbul, so I flew in halfway around the world. And then the other halfway around the world was last week on a different conference. Let's get connected. If you're not connected with me on the LinkedIn, please do so. There's a QR code, or you can find me on LinkedIn. A little bit about myself. As she said, I'm a director of services at Attendees, and what I do at Attendees is we are a support and services provider for ClickHouse. We also have a managed services provider. We have a DBaaS environment, and I run the support organization for our customers, a lot of customers. And I am an open source database evangelist. I like open source. In my previous life, I worked in large corporations that Peter mentioned earlier in the talks, very, very large companies, and doing very, very large databases using enterprise databases. But recently, I worked in Chista Planet, and all of those are open source databases. At Alkinity, we are also open source company. This is an open source conference. We do support for open source ClickHouse. We have a release for open source stable releases, and we contribute back to open source ClickHouse. We also have an engineering team that provides tools like Operator, backup tools, and some other monitoring tools that we provide for our customers, and they're all open source. You can see it on the GitHub. Other than that, I participate in open source events, and I get influential on the database community. Also, I have co-authored 2 books. One of them is MySQL Cookbook. The other one is a design and database design and modeling book for Postgres and MySQL, just recently released. And also, I am part of the Oracle MySQL community as a rock star, and we do actually have events around the world for Oracle events. And that's about myself. And the reality is, sorry, I have to go back over here. I was born to sail and forced to work, and the reality is I'm an avid sailor. I do sail, and I like sailing, so we have to do a very fast sailing trivia. The previous talk, the question was, what is the purpose of the boom? So we were asking about the boom. The boom is the, horizontal sprout of the mast. So what is the purpose of a boom? So it's not shown on the sailboat over here. Anyone? Yes, correct. Thank you very much. Okay, we have to go fast. So today's agenda, let's go back to the subject. I usually do database talks, and I'm an expert in databases, but we're going to touch base on observability and database and take a look at that, how we can combine these two. So some of the basics on observability. Introduction to ClickHouse. I think there's a talk after me on ClickHouse, so it's good that I don't have to go into too much deep into that. OpenTelemetry, OTel, is an open source observability tool. We'll talk about that and some of the other comparisons that I'm going to try to run through during this short time frame. So, what are the challenges with the telemetry systems? So the main challenge is we have too many tools for metrics, logs, and everything else that around the traces. So according to Grafana State of Observability report, minimum number of observability tools deployed in a typical organization. Any guesses? How many tools that you would deploy in generally to have an observability on your systems? Guess? 6. Okay, that's a good one. And this is minimum. And then this makes things very complex and difficult for people who are actually designing these systems. So what are we actually looking into? Matrix, traces, and logs. So in matrix is basically we see is there a problem? And you're looking at a dashboard. Is there a problem? You see peaks and valleys and then going up and down. There are some traces, and where is the problem? And then there are the logs, and basically what happened in a given time. So those are the logs. So we all need all of these to have a conclusion on what happened or what's happening in our systems. This is not for only database. This is for the entire ecosystem. It could be, you know, your microservices. It could be your database services or other services that you provide for your customers. Some of these tools you already know. No need to go into that. Grafana is very popular. Kibana and PMM is a database monitoring and management tool by Percona. All open source mostly, and they can be put together as an observability tool in once. So OpenTelemetry project is, if you look at that, to achieve observability, basically on visibility and understanding of your system, you actually connect them to OpenTelemetry collector, and it has the traces of logs and metrics and traces for the backend. So what are we storing over here? We store all these, other than the matrix, we also have the metadata, graphs, topologies, snapshots, and configurations. Basically the whole ecosystem, because if you don't connect the dots, it will not have giving you the big picture. All right, hopefully I'm not going too fast, but I just want to really run through these important slides over here. So we have, we said we have multiple sources, and then we have different sources that connects into a pipeline that goes into a storage. And that's the key part that I want to emphasize over here. It's a challenge, okay. So we have all this data, and then we need to store them, and then we need to be able to use them eventually. So the other systems, don't we have systems like Prometheus, Victoria Metrics, and other time series databases? Yes, we do. Can we store them in some other OLTP systems like Postgres and MySQL? Yes, we can, but they are not scalable. So that's where ClickHouse comes over here. It shines, and then ClickHouse is SQL compatible, massively scalable, and extremely fast. Really, really fast, because it's a columnar store, unlike the row-based B3 index type systems. It has a columnar vectorized execution, and it makes things very fast for this type of system. So let's take a look at it. What other features it has? Full text search, efficient compression, real-time analytics, relational, and petabyte scale. So when I say efficient compression, do you know what level of compression we can get on a log-based data, for example? It's text, bunch of logs. You can have a very large system. So one of the customers that we were discussing about it, I was saying like, okay, you will get, you know, 50, 60% compression. She said, no, we're getting 90% compression on our log data. So this is extremely important that you have this type of compression on a very large and efficient system. Of course, that's also cost efficient. You're not going to pay for the disks. Disks are expensive, and then you don't want to retain them. Going forward, OpenTelemetry and ClickHouse actually pair really well, because OpenTelemetry is a very standard traces and metric logs system that actually is kind of a framework, and a ClickHouse gives you a column store on to match with this system. So ClickHouse has an extremely fast ingestion system with the merge tree family of its engine, and it basically takes the input on the data with the index and columns as parts, and then they actually written into bigger parts. While doing that, you actually have the compression, also update and deletes, also rewrite parts, so you have a bunch of parts, and then those parts get merged, and then it becomes a merge tree family of a table. So this table, at the time of this table, you already have some functions that can be built in, aggregate functions, and then you can actually have a very efficient table that is already ingesting data into it. I think we will go into that on the next session. So let's go that, and this allows fast writes. Why we need fast writes on OpenTelemetry-like system? Because we're ingesting a lot of data that we may not need at the time, because we don't know what happened, maybe we will visit, or maybe we will not. So it's time-friendly, easy to clean up, and cost-effective. So we'll look into that, how it achieves that. Basically, we have materialized views, which is very good. Ingesting data, you can actually change into a materialized view. You can actually have your business logic implemented during the ingestion of it. And then there's a TTL. There's no need for purging. It'll expire as soon as you set this one in the beginning of when you create the table for the data that you're storing. It also allows a tiered storage. What does tiered storage allows? Again, on top of a compression, you're actually saving dollars over here. You can have the fast, slower, and the slowest like object store within this system if you set it up right. So these are the considerations that you need to know before you're getting into it. If you actually experimental, it's okay, but if your implementation on a large scale, you might want to consider this factors before setting it up. Later on, it is possible to change these things, but as the systems get larger, operational, you'll be. So there are some other integrations within the ClickHouse ecosystem. Kafka stands out over here, very popular ingestion engine for the data streaming data and the data pipelines. And Kafka engine, using it with the materialized view is very popular, so that's something you can think. So now we're putting together the dots over here and connecting. So you have Prometheus, Fluently, and eBPF, of course. It's very popular. We'll talk about that a little bit. And then goes into OpenTelemetry collector. So this collector has a direct link to ClickHouse, and it can actually digest all that data into ClickHouse. Okay, more benefits. So we talked about the compression, and you can have an unlimited cardinality, and it actually likes the cardinality and also horizontally scalable. So ClickHouse does support partitioning within a table. It does support sharding. It does also support replication. So basically, depending on the need and the size of the data that you will be storing, you can have all these features already within the ecosystem. Of course, there are some challenges. As everything else, there's no silver bullet. We always say that. SQL is not PromQL. If you're like already have a PromQL environment, and that you need to change into that. But we're always thinking on SQL. Once you're on SQL, you can basically write queries, create dashboards, use other open source tools like Superset, Apache Superset, and create like dashboards. This setup would be very complex for small data sets. You know, if you're not running a large organization, and a lot of this may be overkill, and there's no turnkey solution in this sense. But we'll look into that. And last but not least, OpenTelemetry doesn't have any UI. So you actually don't have a UI that comes with OpenTelemetry. So we have the OpenTelemetry collectors, linked everything back to ClickHouse. You don't have some sort of a administration or management system that comes along with it. Of course, you can have dashboards with Grafana and other tools, but this one doesn't have. So now we have the bigger system that's collected. So OpenTelemetry has other bells and whistles. We don't have time to get into those. You will have application SDKs, collection sampling and processing, and basically that goes into storage tier. I think we will mention the alerting that can be also configured at the end of this whole pipeline. Let's say you have collected everything, and you can use some other tools like Grafana, environment to do alerting also, integrations, or you can actually have APIs that calls PagerDuty and Opsgenie or something like that in that sense. Okay, so now we have come to a point where we have OpenTelemetry, open source, and the framework that comes to collect all the traces, logs, and metrics. And then we have a database called ClickHouse, and then we actually configured for our use case. But this is still a basically DIY project at the end. But in this sense, we have a couple of other options over here. Over here on the options, Coroot and qryn stands out. And let's take a look at these real quick to have understanding of it. So Coroot is mostly no-code observability platform. It's open source, and it can be configured to run the entire system that includes both application, network, and database operations. And then it can do basically service discovery, linking, and then has a nice UI, will give you the application control plane and monitoring features within the built-in ecosystems. It is using OpenTelemetry and also eBPF tracing. So it allows users to have a much faster start than putting it together as a whole. So you can actually have logs, instances, and CPUs. So it's worth to give it a try in terms of having a solution that's also readily available. So qryn is also another tool that comes with a logql, promql, and tempoql for OpenTelemetry sources. And it can also use the ClickHouse as a backend in the sense. So I'm no expert on neither of these tools. We've used other tools in our systems, mostly exporters that goes into Grafana, and then we have custom alerts or alert manager integrations in our database systems. But when it comes to whole ecosystem like microservices that includes your application pieces, that may be much more faster start, but having a ClickHouse over here is important because once data is on the ClickHouse, you have better options to query and get to it. Okay. So if we compare the two, we have eBPF-based node agent over here, and whereas qryn uses its own collector and exporter. So it's kind of a non-standard compared to eBPF because eBPF is used other places, as you already know. OLTP ingestion via collector gateway. This is something Coroot does support, and it has OpenTelemetry exporter schema and needs schema profiles. So there are some differences between the two if we shortlist these tools, and you can check those out and basically come to conclusion. So for the schema considerations, we talked about the compression. So there are multiple compression options in ClickHouse. You can choose, but ZSTD compression is one of them. So we also recommend delta encoding over here. So there are Bloom filters that you can set for the logs. And of course, merge tree family is one of them, is partition on time. Make sure you, like I said, make sure that you partition and set these before you ingesting large sets of data so that you don't run into operational issues later on. And then we recommend 7-day TTL for the large systems, but you can of course keep it or set it up in a tiered storage to keep the data older for the other storages that you can set up maybe slower and cheaper, eventually putting them up to, because of some of the logs needs to be kept longer than 7 days from a security and compliance perspective. So basically that is something you need to consider over here. From the ClickHouse side, we have OpenTelemetry collector over here, and then we have the metadata mapping, and there is a full text search and materialized view that it's come along with this. So these are actually helps this setup complete. And in the qryn you have some other options over here. I think it still uses the ClickHouse features, but it's slightly different than the Coroot. So, okay, high availability considerations in the architecture. So let's take a look at it. We actually recommend having a multiple OpenTelemetry collectors deployed so that you don't run into issues with single one. And of course, setting up a ClickHouse as a cluster is advised with replicas. We usually have at least 3 replicas just in case. And then, of course, ClickHouse comes with a keeper, zookeeper, and ClickHouse keeper. So we also run at least 3 zookeeper instances for the metadata. And then we also recommend using alternative operator for ClickHouse to have operationally scalable environment for the data storage. So the alternative operator, this open source tool that actually allows PVC management, rolling upgrades, and it comes with the built-in monitoring with the ClickHouse exporter. So little bit on the alerting and other considerations. We have Grafana-based thresholds you can set. You can also have integrations with email, Slack, or PagerDuty, like I mentioned earlier. And I think for the simplified management, this is something we've been researching, and actually there are some other projects in the market that actually uses OpenTelemetry. OpenTelemetry is gaining more popularity in terms of becoming a de facto standard for all these collection of metric logs and traces. So from the cost management side, you can actually have a complete picture with the OpenTelemetry and ClickHouse combined, the two. And that concludes my fast running. I hope I'm still on time. And I have put in the resources. The slides will be available. Links are over here. You can always check these out. And if you have questions, you can ask over here, or you can ping me anytime. Thank you.
Thank you so much for the sharing, Alkin. Yeah, if you guys have any questions, yeah, all right. Yeah, we have one question here.
Hi, I have a question about the table design, and for, let's say, you ingest logs for multi-tenant. Do you make a table for each tenant, or do you make a cluster for each tenant using the operator, or what's the way of segregating that you would recommend segregating?
So, so let me repeat the question if I understand correctly. So you're saying, do we need a table for each tenant?
So I guess something I'm missing is, my understanding is that joins are kind of slow in ClickHouse, so people shove everything in one table. Let's say you have data from different tenants that you don't want to mix in the same table. Would you make like one table for each tenant, or would you make one cluster for each tenant?
I would make one cluster for each tenant, in the sense, depending on the design, but it could be the other way. If you partition it by tenant, then you don't need to do that. You can have it in a single cluster, partitioned by tenant. And you can also have an option to do multiple tables. But ClickHouse is not great at joining tables, but it's great at having one large table with denormalized schema design. So you can have multiple columns in it, which is perfectly fine.
Thank you.
All right, thank you so much for your questions.
Do have one more question over there?
Yeah, we need to make it very concise.
Okay.
Thank you for the discussion. Question from my side. ClickHouse supports low cardinality engine for the columns. Does it support low cardinality for the nested maps? For like, you could use it for resources, so you could utilize even less space for the resource column?
That's a good question, but the low cardinality, it doesn't like low cardinality. It likes the higher cardinality in the sense. Is that?
I mean, basically resource is just something which is relatively low cardinality unless you have billions of machines or something like that. And low cardinality is just a string interning to replace strings with integers. So if you would basically do integer maps, you would save a lot of resources to not compress strings even further, just compress integers later with ZSTD.
Yes, you're right. See, I think the way that I take this, OpenTelemetry has a schema that's mapped for ClickHouse. So it is designed to way that it works even for the low cardinality columns that will match to the service that it's tracing. And I'm assuming that the way that it's implemented, that it's efficiently able to trace back to the rows that it's looking for. So I hope that answers your question.
Okay, thanks.
All right, thank you so much for all the questions, everyone. As we run out of time now,